Hello everybody, I'm Danial Ahmed. I am a cloud security architect. Today I will be showing you a different attack path than we discussed in the last video. This will be totally related to how a user having a certificate user role on a key vault can actually use and access those certificates inside of it. And even if the key vault is not allowing us to download a certificate's private key, we can still locally make up the JSON web token and we can sign it using the endpoint in the cloud. So we can get token and we can authorize as any app registration that is using the certificate. This is the lab environment that we are going to work on. There is a app registration that is named of SecOps app registration, and it is using a certificate from a key vault, and this key vault is SecOps key vault. So first things first, let me show you how it actually works, how a certificate can be used to manage authentication and authorization. So for instance, what happens is if a user wants to access this app registration and we have connected a certificate with this app registration, the user can simply send a JSON web token to this app registration. And if this JSON web token is valid, he will be granted access. Now, in what way would this JSON web token be authorized? So basically, if this JSON web token is the hash of this token, of course, is encrypted using the private key of the certificate, then it will be validated. How? Because this app registration has this certificate within it. It will make sure that this public key is validating the JSON web token beforehand. So when we send the JSON web token to the app registration, it will check with the public key whether this is signed using this private key or not. If the mathematical relation matches up with this JSON web token, and the JSON web token in this matches the public key's relation to the private key, then of course it will authenticate, else it will drop the request for the user to gain access to the app registration. Now, we have already made an app registration. We have already added a certificate from this key vault into the app registration, and the attack path is starting from this user who has an access on the key vault, and the role is actually certificate user, so he can use the certificates. But one thing to understand is that the certificate that we made is not exportable. So if I can show you here, when we were creating the certificate, it was not exportable. So we cannot export the private key. We can only query the endpoint and we can make it sign our JSON web token, but we cannot actually download the private key and do it all locally. So this is one thing. One more thing I would like to show you is this is the key vault crypto user. This is not the role that the user has. He has certificate user, but it is completely similar in regards of what it does. You can actually see that for this role, key vault crypto user, you can see that we have a role in the vaults and keys as signing. So we can sign we can do this action of signing. So we can sign anything with the keys, but in a certificate role, like a key vault certificate user, it will be the same. It will actually just be key vaults, certificates, sign and action. So we can sign anything. We cannot download the crypto key, but we can sign it. Okay, so let's move back to the attack path. As a user admin, we got the credentials. The initial access is already there. We will check out what roles we have, and we'll find out how many scopes we have the roles on, and then we will enumerate both differently. First, we will enumerate the vault, and then we will enumerate the roles that the app registration has, because we will find out that the certificates are connected to an app registration and what that app registration has roles on in the directory. So we will be doing the enumeration in two parts. We'll first find out the scopes and the roles that the user admin has, and then afterwards we'll find out the certificates and what roles do the app registration has that is connected to the certificates. And afterwards we will actually generate a script. What this script will do is actually all the enumeration that we have done till now, the tenant ID, description ID, the app ID for the app registration, the certificate thumbprint, all of these enumeration data that we obtained, we're going to write it in a script, and we'll create a JSON web token locally, and then we'll send it to the key vault, and it will sign it for us and give us back the signed hash. This hash will be used to gain access to the Microsoft Graph token from the endpoint of MgGraph. So this is the whole attack path, and let's start with the implementation. Let's just connect with the account first. So we already have the data. Now we are authenticated as the user. So to find out what user we are authenticated as, we can simply type get AV context. So we are user admin. Now, first things first, what an attacker does after gaining access to any user is getting the roles. And with the roles, we also find out what scopes those roles are on. So we got these roles in our users, and these roles exist as Key Vault crypto user, and we also have a certificate user, and we also have a reader role. And the scopes for all these three roles are SecOps Key Vaults. So we got one thing. While enumeration, we got actually the role definition, and we also got the SecOps Key Vaults. This is the name of the vault, so we can save it somewhere. Now, what we can do is we can find out what actually is inside of those vaults. So what we can find out what actually is inside of these vaults, because we already have a reader role on it. So let's see. So we can actually enumerate the certificates inside of this key vault using this. So we can see there is a SecOps AppReg cert, and this is the thumbprint. Now this thumbprint is very important because we will be using this when we are creating a JSON web token locally, and then we're going to hash it and sign it using the key vault access that we have online. Now, for now, we'll be saving this, as well as we'll also be saving this, because we are going to enumerate the actual certificate on what actually it has. Because the certificate can give us a lot of information, because we don't really know what this certificate is signed to, and we can see what app registrations or what other kind of resources this certificate is providing authorization for. We'll just find out the certificate name, which we already have. We already have the vault name, and we'll figure out everything about it. So for that, we are just using select object asterisk. So everything about this certificate and this vault inside of this vault will be thrown out. So we get a lot of data, and first things first, we see the subject and the issuer. This is very important. Most of the times this is equal. The data inside of the subject and issuer are equal, and they map to the resource that the certificate is using. So for instance, if I was creating a certificate after I made an app registration, and I was solely making this certificate for that app registration, I will write the name of that app registration. So we can think about this name as the app registration itself. And this is the serial number, this is the date it was assigned, thumbprint, this is very important, we'll use it later on. And this is the actual public endpoint. So this is a public key search, and simply there's nothing more important for us here. We'll simply use this information that we got to enumerate the app registrations. So for that, we'll first find out the actual SecOps app registration, and to find that, we'll find out the application module and searching it up. All right, so when we ran this, we found out that there is actually an app registration with this ID, and this is the app ID. Now we will also be saving this, because this is also what we need for the finding out the ID of this application. So we'll just use this command to get the application display name, and we'll save it into an app variable. And when we print the app, we'll figure out a few more things about this application. Its name, of course, SecOps app registration. We'll find out the ID. We'll also find out the key credentials that it is using for authorization. And this is very simple, that we just found out this is the certificate thumbprint. And you can see this is the same thumbprint. So this is actually the same certificate this app registration is using. One more thing is very important here, is this required resource access. So these are the access roles that this resource has, app registration. And if I can enumerate all these resources, what they do, these IDs, what they do, or what these IDs belong to, we can simply use. Now we will figure out what these roles IDs are, but first we have to find out the service principal attached to this application. So we know that these applications don't exist in a silo. They have a service principal attached to them, and these service principals are what actually have those roles and are used to coordinate with other resources in the tenant. So to find out that service principal, we'll just get the application ID, and we'll find out the service principal of this application ID and save it into a variable name SP. And when we print out the SP, we can see that this is the service principal that is attached to the application ID. This is the app registration's service principal. Now we can remember when we talked about these roles, we can figure out what these roles actually do now. So now we can simply save the service principal ID as this, and this is basically the same service principal ID that we saw here. Now to figure out the role assignments, we can simply invoke the REST method on this graph endpoint. We just have to change the service principal ID after the service principals so that we can make sure that it is targeting this endpoint. Now, all right, so we get this. Now this gives us actually the scopes and the roles that we have on the service principal. Now to find out what these roles actually do, because you don't see any name in these roles, we just only see the app role ID and the ID of these roles. So to figure out what these actually do, we only see that the data that we get is Microsoft Graph on the resource display name. So we are getting some kind of a role on this resource, a Microsoft Graph, but we don't know what kind of role there is. We're simply going to find out the assignments. Similarly, same thing, we're doing exactly the same thing. We're finding out the actual role assignments in this service principal ID. Last time we did this the same thing, but without the names. Now we're going to find out the names as well. So what will happen is when we run this, what it will be doing is it saved the graph SP in the last commands that we used. I will be saving all the commands and I'll be putting it in a text document and it will be in the description below. So what it does is it is using the graph service principal endpoint that we enumerated right now, and it will find the app roles. And for every app role that we got, it will give us a name. So this is, ignore this for now. We just added these comments. So it is user read write all and directory read write all. So we have these roles in this Microsoft Graph endpoint. On this resource of Microsoft Graph, we have these two roles, and these are for the service principal. Mind you, we're not in the service principal right now. We are only using the certificate to enumerate all this. So now that we have all the data that we have, we needed the thumbprint for the certificate, we need the tenant ID, we needed the application ID, we also needed the subscription ID. We have everything, and now we can try to create a JSON web token locally, and then we'll print that out and use our local hashes to hash it, and we'll send this hash to this key vault and it will sign it for us. After it signs us the hash, it will give us back the hash, and we'll use that hash to find the MgGraph endpoint and get a token for that. Now, so in this attack path, we are right here. We found out the roles. We figured out there is a SecOps key vault, and we also found out the certificate enumeration data. We found out what these certificates are related to and what roles it has. We also found out there is an app registration. We found out that this app registration has these two user.rewrite all and directory rewrite all access on the Microsoft Graph in the tenant level. And now it's the final task that we are going to use all the data that we got, and we are going to create a script. Now we have already created the script, and I can show you the script here. So you can see this is the tenant ID. We imported the base64 JSON hashlib time UUID requests, and we are just using these to encode and decode the thumbprint. We are also going to use JSON for making the JSON web token. And the things that we needed was these three. The tenant ID we already got from the enumeration. We got the client ID. We got the thumbprint for the certificate that I showed you earlier. The key ID is basically it is something we make ourselves. It is just the HTTPS endpoint for vault.azure.net/keys, but after the keys you have to write the name of the certificate, and before the .vault you have to write the name of the key vault. And we are simply using thumbprint to convert into binary, and then we are going to save this binary base, and then we're going to convert it to a base 64 and save it into x5t and x5t variable. This is very important because this is the variable that the Entra ID checks for to see which public certificate they need to enumerate when we are sending the JSON Web Token. We are using the same algorithm, type Java JSON Web Token. X5t is simply this data that it got from the thumbprint, and we're going to write these claims. For things short, we are just making a JSON Web Token. We are going to hash it, and then we're going to send it to the endpoint and get a signed hash back. After that, we're going to print that out in a token.txt file and also copy that into our clipboard. And similarly, we can save this somewhere and we're going to run it. I've already saved it. Let me. All right, so we needed a virtual environment. I made the virtual environment. We just need to install these Python packages. Once they're done, we can simply run the script and we'll get the token. I've saved the script in the tools folder and we can use. So it will ask you to log in as the user admin because that is what the service principal is asking for, because you have the certificate user role on the key vault in this user. So simply we're going to copy paste this and enter user admin. It will grant the access to this user and you'll figure out that, okay, the token is copied. Now, so it's saved in the d token.txt file and it's also copied into the JWT. I'll just real quick save it. All right, so what we can do is we can go to our D directory and the token, we can see the token is here. And we're going to save this inside of this. And we cannot use this as it is because we need actually to make it a secure token. And for that, we're going to convert this into a secure string and simply use this. Instead of the token, we're just going to use the JWT. Now, this JWT is usable. So we can ask the Microsoft Graph endpoint to authenticate as that. So we're going to connect with the Microsoft Graph endpoint. And before we connect, I will show you where we are in the attack chain. So we created the script, we ran it, and now we also got the Microsoft Graph token, and we're going to run it. So you see, if we try to use the same JSON Web Token, it will not allow because it's not a secure string. So we just converted it to the secure string beforehand. So now it's allowing us. So if I get mg context, we'll figure out that we are now as logged in as the service principal SecOps app registration, and now we have access to read write all and directory read write all as well on the client ID and tenant ID. This is the whole attack chain completed. Thank you for watching. Assalamu alaikum.